Hi everyone, today we're going to talk about curve fitting with exponential and logarithmic models. So this is something new that we haven't done yet in some respects, and in some respects it's not so new because it has a lot to do with the calculator and how to get information out of the calculator. So before you start watching this video, make sure that you have your calculator handy. You can go ahead and also print off the assignment for today as well, so you can kind of see how we're going to go about doing each of the problems that are on the assignment. Feel free at any point to pause the video, rewind it, and go back and watch different parts again. But this is very calculator driven, so you want to make sure that you have that handy. Okay, so let's talk about the first part here is determining if we actually have exponential data. And we've done stuff like this before. We've looked at different ways to figure out if our data was linear, quadratic, and those sorts of things, or taking the difference and finding out if we get a first difference or a second difference or a third difference, etc., etc. We're going to really apply that same sort of theory here. How we determine whether or not we have exponential data is simply by, instead of taking the difference, we're going to find the constant ratio. And how we do that, it's very straightforward, it's very easy. This first problem here on the left represents linear because you would take the difference, right? We would do -1 minus a -3, so that difference would be 2, and then the difference between those is 2, and the difference between those is 2, and the difference between those is 2. And that's our first difference, and because our first difference is constant, that means it's linear. We did that a while back. Here, because we're determining whether or not it's exponential, what we're going to do is we are going to find our constant ratio, and all we're going to do is, instead of finding the difference, take the quotient. That means divide. So I'm doing 1 divided by 1/2, and that gives me 2. If you do 1 divided by 0.5 in your calculator, you get 2. So then I'm going to do the same thing. I'm going to do 2 divided by 1. That also gives me 2. And then I'm going to do 4 divided by 2. That gives me 2. And then I'm going to do 8 divided by 4, which also gives me 2. 2 is my constant ratio. Okay, all I did was divided this by this, then divided 2 by 1, then divided 4 by 2, then divided 8 by 4. Okay, you need to make sure it's constant all the way through, and if it is, then you have exponential data. So this is in fact exponential, and that constant ratio is 2. Let's try a couple more examples. Let's look at this first one. If I do 2.6 repeating, I'm going to do it right in the calculator. If I have 2.6 repeating, let me clear this out here. So that's 2.6 repeating, right, divided by, oh, sorry, let me clear that out. So do 4 divided by 2.6 repeating. So 4 divided by 2.6 repeating, and that gives me 1.5. Okay, let's then do 6 divided by 4. That is also 1.5. Then let's do 9 divided by 6, 1.5, and then 13.5 divided by 9. 1.5. So all of these, right, when I did the division of 4 divided by this, and then 6 divided by 4, and then 9 divided by 6, 13.5 divided by 9 was all the same, and so that would be yes, and my constant ratio was 1.5. Okay, let's look at B here. I'm going to do the same thing. I'm doing 2 divided by -3. That gives me -0.6 repeating. Then I'm going to do 7 divided by 2. Oh, and that gives me something totally different. I don't even need to do the rest of it because already I have two things that aren't the same. So the answer here would then just be no. Okay? So that's pretty straightforward how to determine whether or not you have exponential data. But now let's talk about when we're given exponential data and we have to find the model that goes with that. Here we're going to get pretty intensive with the calculator. We're going to do some things that we haven't done yet. I just want you to sort of follow along. Like I said, pause the video and see if you can do the stuff on your calculator as well. Okay, so we're given a table and it's talking about approximate values of diamonds of the same quality. And it says find an exponential model for the data. Okay, so the first thing we have to do is put all of this data in our calculator. This part is nothing new. You click the stat button, that's 2 over from alpha, and you're going to press enter on edit. Okay, and in L1, you're going to put this left-hand column. So 0.5, 1, 2, 3, and 4. I know I'm doing this kind of fast, so if you need to pause the video right now to go ahead and enter all of this into your calculator, go ahead and do that. 60, 1580, 2150, and 2900. Okay, now that is all of the data. We want to find an exponential model. So to do that, here's what you're going to do. You're going to press Stat, and then you're going to go over to Calc. And we've done these before. We did the linear, we did the quadratic regression, we did cubic, we did quartic, we did those. And if you keep scrolling down, you'll see exponential. There it is, option 0, EXPREG. That's an exponential regression model. That's how we're going to get that equation. Okay, so we're going to press enter on that. And now what we want to do is we want the calculator actually to store that in Y1 so that we can go back and graph it after, which we're going to need for the second part of the problem. So to do that, we've done this before as well. You hit vars, arrow to Y vars, enter on function, and enter on Y1. So vars, Y vars, enter, enter. They'll bring you back here, and then press enter again. You'll see then you have all of the data you need here. You have your exponential function a times b to the x. That's stuff that we've done before. You have your a value and you have your b value, and then you'll see here this r value. Remember, the closer that r value is to 1, that means the closer all of that data falls to that line of best fit. Okay, r squared we don't need to worry about at this point. All right, so it says to find the exponential model. So remember, it's y is equal to a times b to the x. We were told what a was and we were told what b was. A was 814.96. So 814.96 times our b value, which is 1.38. 1.38 to the x. So that is that model, exponential model. Okay, now it says use the model to estimate the weight of a diamond worth $23.25. This is where it's a little different than what we've done before. Okay, this is the value we have. We're actually given that y value, not the x value. So here's how we're going to approach that. What you want to do is you want to go back to y equals. Notice that first part was stored in the calculator for us. Okay, that original equation is already stored in the calculator. What we want to do is put this other y value into y2. So I'm going to put that into y2, 23.25. Okay, so I just put that into y2. Now, what we're going to do is we're going to graph these two on the calculator, and then we're going to find where they intersect, and that'll give us this x value that goes with that y value. Okay, so, and this is the same approach we're doing for all of these problems. We put that y value in y2, and then we'll graph and find the intersection. Here's what you need to do, and I need you to follow these steps. steps. Again, if you need to pause along the way, go ahead and pause the video. The first thing we need to do is to turn our plot on. So you want to arrow up to where it says plot and press enter, and then when you arrow off it will be highlighted. That means it's going to plot these points for you. Now in order to graph it, we're going to hit zoom, and then we're going to go down to zoom stat. Okay, that's option 9. Press enter, and you'll see those are the points that came out of this table that we entered into the calculator. That's our first part. This line that's drawn here, that is that 2325. That's that y2. Okay, that's why we put that in the calculator. So now we have two different lines. To find the point of intersection, here's what you need to do. Hit second, trace, and we're going to go down to option 5 that says intersect. Okay. Now this is where it's very, very easy. You hit enter again, and hit enter again. So you're just hitting enter 3 times, and it'll come up on the bottom. So when y is 2325, x is this. Okay. So x, remember, represents this data here. So that you would say, well, it's about 3.26 carats. Okay, so it says use the model to estimate the weight of a diamond worth 2325. Well, that would be about 3.26 carats. And that should make sense, right? If you look over here, 2325 falls between these two numbers, and 3.26 falls between these two numbers. I mean, that should make sense. Okay, but that's how you're going to approach all of these problems. Okay, let's look at this second one. We're going to go ahead and put this data into our calculator. So go ahead and do that right now. You can pause the video, and I'm going to do that as well in my calculator. So let me go ahead and do this. Like I said, if you want to pause so you can enter it in, then you can restart the video. You can go ahead and do that. I'm actually going to pause the video here just so I can put the data in and not waste any time. So I'm just going to pause here, and I'm going to put the data in. Okay, everybody, I have all of my data in my calculator. I'm going to go back to y equals and just clear out the other data that I had in here because that was from a different problem. Okay, so I put all of my data in. I'm going to go stats, calc, and I'm going to go down to exponential regression. That was option 0. Press enter. Remember, we want to store this in y-vars, so we're going to go vars, y-vars, enter, enter, enter again, and now that is stored in y equals. So our equation here, the first part is find the model, so be y is equal to a times b to the x, and let me pull my calculator back up. So a is 199.29. So y is equal to 199.29. And I believe that b was equal to 1.25. So that would be 1.25 to the x. Okay, so that's the first part. Now, it says, when will the number of bacteria reach 2,000? I'm actually going to stop the video here because I'm going to run out of time before I can finish it. I'm going to pick up the rest of this problem in the next video. Okay, thanks everybody.